Good morning. This is Hope Reactor. Now, let's begin today's news.
What if I told you that the biggest breakthrough in modern cars isn't the battery? It's a tiny semiconductor hidden deep inside the vehicle, a part most drivers will never see. Yet it can make a car lighter, more efficient, and able to drive much farther on electricity. Today we're exploring the technology that's quietly transforming the automotive industry. It's called SiC power semiconductor, and Japan is leading the world, the hidden brain inside every electric car. When people think about electric vehicles, they usually focus on batteries. But batteries alone don't make a car move. Electric motors require alternating current, while batteries store direct current. Something has to convert that electricity. That's the job of the inverter. At the heart of every inverter is a power semiconductor. Think of it as a traffic controller for electricity. It decides when, where, and how electrical power flows. The better this tiny component works, the better the entire vehicle performs. Why silicon is reaching its limits? For decades, power semiconductors have been made from silicon. Silicon changed the world. It powered computers, smartphones, and countless electronic devices. But modern electric vehicles demand much more. Higher temperatures, higher voltages, greater efficiency, smaller size. Silicon is approaching its physical limits. That's why engineers have turned to a new material, silicon carbide, or SiC. Why SiC is revolutionary? SiC has several remarkable advantages. It tolerates much higher temperatures. It handles higher voltages. Most importantly, it wastes far less electricity as heat. Less wasted energy means greater efficiency. Because it generates less heat, cooling systems can be made smaller. Smaller cooling systems reduce weight. Saving space also allows manufacturers to install larger batteries. One invisible component improves the performance of the entire vehicle. Toyota's historic decision. Toyota recently made a major move. The company introduced SiC power semiconductors into the inverter module of the latest plug-in hybrid version of the RAV4. This is more than a simple component upgrade. It represents a new generation of vehicle design. The results are impressive. The inverter module became approximately 15% smaller. The power module became 18% lighter. Battery capacity increased by about 30%, thanks to improved packaging efficiency. Most importantly, electric driving range increased from approximately 95 kilometers to 150 kilometers. For many drivers, that's enough daily driving without using gasoline. That's the power of invisible engineering. Japan's quiet strength. Building SiC semiconductors isn't easy. Growing high-quality crystals takes years of research. Manufacturing requires extraordinary precision. Testing demands world-class reliability. No single company can do it alone. Behind every advanced vehicle is a network of specialized manufacturers, material suppliers, precision machining companies, inspection equipment makers, packaging experts. Many of these companies are relatively unknown outside Japan. Yet together, they create some of the world's most advanced automotive technologies. This manufacturing ecosystem is one of Japan's greatest competitive advantages. Beyond cars, the importance of SiC extends far beyond automobiles. Artificial intelligence data centers require enormous amounts of electricity. Renewable energy systems need highly efficient power conversion. High-speed rail, industrial robots, factory automation, aerospace systems, all of them benefit from advanced power semiconductors. Industry analysts expect the Japanese SiC market to grow from roughly $4.6 billion, equivalent today to nearly $29 billion, equivalent by 2035. That's more than 6 times larger. Technology is national strength. As competition intensifies, advanced semiconductor technology has become a matter of economic security. Many governments are strengthening policies to protect critical technologies from unfair acquisition and unauthorized transfers, because advanced manufacturing isn't just about business anymore. It's about national competitiveness. Countries that master next generation semiconductors will help shape the industries of tomorrow. Positive shift opinion. I'd never heard much about SiC before researching this topic. But if technology like this helps improve fuel efficiency and lets electric cars travel farther, that's something everyone can appreciate. What impressed me even more is that it isn't something companies can simply copy overnight. It represents decades of accumulated experience. precision manufacturing, and cooperation among countless Japanese companies. Sometimes the technologies changing the world are the ones we never notice. Ending. When we admire a car, we usually notice its design, its speed, or its comfort. Rarely do we think about the tiny semiconductor hidden inside. Yet that invisible component is helping shape the future of transportation. Japan's greatest technologies are often the ones you never see. Invisible innovation, visible impact. The more we learn, the more hope we discover. If you enjoyed this story, subscribe and join us as we explore more hidden technologies changing our world.